there are some fundamental mistakes that we have done. Let me quickly tell those mistakes which I found. One is when you use your equations, I can't see some of you all are using indicating direction. So if you do not indicate the direction, what happens is, when you substitute your values, the sign will be not accurate. So your final answer will be affected by the wrong substitution. That's a mistake. And also, when they have mentioned that the height is negative and positive. I saw in some of your answers that you all have mentioned the ball is traveling in opposite direction. What does that mean? What did you mean by the opposite direction?
Since downward direction now, the ball is kicked high, so when it's kicked, it's the motion is upwards. Yes. And then it reaches a maximum height and then comes down. So that downward motion is in the opposite direction of the initial direction of initial motion, right?
So you can have a positive displacement when it is moving downwards, right? Isn't it? While the ball is moving downwards, there can be a positive displacement as well, right? So 1 meter. 1 meter above the initial position. That's positive, but the ball is moving backwards. Right? So the ball is moving backward is not a, in the opposite direction will not be a correct answer. Like we need to be very careful when you write. I have checked your answer scripts, not yours as in students' answer scripts. And when students are wondering as to why they do not get marks for their answer, one of the main mistakes that I found was that the words that they have used. They have the idea, but the words that they have used weren't right. It doesn't give the correct meaning. And some of you all have mentioned going backwards, right? If you mention it as backwards, it's like forward and backward. That's not correct. The ball is not going backwards. So that means you consider upward direction as forward. No, you can't consider that. If you are saying forward, it has to be like horizontal. Right? But vertically upwards and downwards would be fine. But the problem is, even though when the ball is going downwards, the displacement can be positive. Like it can be above the initial position. Then how would you write your answer? I would suggest you to write your answer based on the displacement, because the displacement is what is negative. Don't talk about the motion. When you ask to write about the displacement, don't talk about the motion. That's where we go wrong, right? This is not like in your year 7 or 8 classes, guys, where you will get some sort of a sympathy mark, assuming that maybe the child might have the right idea, but it is just a way that the child has written the answer. No, they won't give you marks. They are so strict when it comes to these writing questions. Be very careful. Since the height is related to displacement, you need to write your answer based on the displacement. Remember, the displacement is negative. If the displacement is negative, the ball should be below its starting position. That's what you need to write. The ball would be below its starting position. That means somewhere here. This is the starting position, right? If the ball is below starting position, we can consider it as negative. So negative 0.78 should be below the starting position, somewhere below the starting position. So your answer should be based on the displacement. Correct, everybody?
So that would mean that it goes underground or something like that, right?
No. That means it has started above the ground. The ball must have started above the ground. So you have kicked the ball with above the ground. And it has reached the ground. When it is reaching the ground, or probably before it reaches the ground, it can be below the starting position. Right. If you have said the ball is bouncing, yeah, that's correct. Right. So the ball must have started, if we write this answer, that the ball would be below the starting position. So the ball must have started above the ground. Above the ground. So it has some ability to go below the starting position. Okay. So don't talk about the motion when you have to mention about the height, guys. Right? If it is height or horizontal distance, talk about the displacement. Position. Displacement means position. Talk about the position. On the diagram below, sketch the label the predicted path of the ball for angles of 20 and 40. On the diagram below, there is only one diagram. Some of you will have drawn two diagrams. Don't do that. That's another thing, another mistake. You got to draw it on this diagram itself. Why should we do that? Because we need to compare. Compare two of them. That's the reason. Do what they ask you to do, guys. Don't try to do whatever you want. Right. Let's go back to the table. When the angle is 20, the height is +1. When the angle is 40, the height is 4.7. Right. When the angle is 20, height is 1 meter. When the angle is 40, height is 4.7. You should draw like that. It has to be from the starting position. Displacement is measured from the starting point.
Sir, it would not be wrong if we draw another arrow from that like 3.7 from that like the difference, sir?
No, that's fine. That would be fine. Okay. So these are very basic stuff. We should not go wrong in this. Let's move on to the calculation. Right. When it comes to calculations, I must tell you, the same thing I mentioned at the beginning. You guys are not using the direction still, some of you all. When you write your equation, show the direction, guys. Use arrow, either upward or in the horizontal direction, right? And the other thing is figuring out the right equation. I believe some of us have not used the data properly. Okay. Still, you guys need practice, a lot of practice. When I looked at your answers, that's what I can see. Read the question with me. Do it with me. During a football match, the ball is kicked towards the goal at an angle of 15. It's marked here, that's fine. The horizontal from a distance of 11 meters as shown. Horizontal distance 11 meters. The ball has a diameter of 22 meters. So the ball is above the center of gravity of the ball should be above the ground. The path of the projectile must be the center of gravity. Path of the center of gravity. which is 0.11 meters above the ground. The diameter is 0.22. The center of gravity would be 0.11 meters above the ground. And the initial speed is 26 meters per second. By means of a calculation, determine whether or not the ball will pass into the goal. You may ignore the effects of the R resistance. All right. So we need to see whether it will pass the goal or not. How do you determine that? You need to find the height. Find the height. To find the height, you need to use equations in the vertical direction. But then how do you know at which point in time the ball will reach the goal, come near the goal, come to the goal? You know, the time is the linking point, the quantity which links horizontal displacement and vertical, horizontal motion and vertical motion. They have not marked, but they have given the horizontal distance to the goal. You can use the horizontal distance to find the time taken for the ball to reach the goal. So if it's horizontal motion, there is only S equals ut. S is 11 meters. Velocity is 26 cos 15 in the horizontal direction into time. So the time is meters per second. A time is 11 meters divided by 26 cos 15 meters per second. Then you find the time. Some of you guys are still mixing up horizontal motion and vertical motion. When you use S equals ut, you need to use the horizontal component of the velocity. So I can't be spending time telling you what the horizontal velocity. By now, you know it. It's 26 cos 15. And since you have the horizontal displacement, you should know that you can use it to find the time. This is not the first question that we do of this nature. So we have time now. You can find the vertical height of the ball at this time. Use S equals ut plus half at squared to find the vertical displacement. Show the direction using the arrow that you are using the equation in the vertical upward direction. So someone tell me the time.
0.44 seconds.
Right. 0.44 seconds. S equals ut. You got to use the vertical component of 26. That is 26 sine 15 meters per second into time. Time is 0.44 seconds plus half a. We are using the equation. Yeah.
So the time should be 0.438.
0.43.
Yes, sir. 0.438.
438. 44 is rounded off value. Yeah, if you use 44, it will be fine. Right, but if you do not round it off, it'll be good. Half acceleration must be minus 9.81. I'm really surprised to see that some of you all are using plus 9.81. Why? Because you don't show this direction. Don't do that mistake, guys. Now we have to improve your accuracy. Time is 0.44 seconds squared. Okay, find and tell me the displacement.
2.01 meters.
Right. 2.01 meters. 2.01 meters is the vertical displacement. The top end of the goal is for 2.4 meters above the ground. How can we determine whether it reaches the goal or not? Does it reach the goal?
So do we?
Yeah. Yes, come again. Yes.
So we should add the vertical height to the radius.
Vertical height.
Yes.
Vertical height of
Of the ball. You should add the radius to that, right? So
yes, at least we need to add the radius because the ball is already the center of gravity is already above 1.11 meters. Right? We should add at least 0.11 because even though it's 2.01, it's from the center of gravity. No? 2.01 from the center of gravity. So to see the actual height, you should at least add 0.11 meters. So if you add 0.11 meters, you will get the height for the center of gravity. What do we get? Do we get an answer which is less than 2.4?
Yeah, so 2.12.
2.12. Okay. So it looks like it's going to go into the goal. Right? We cannot just compare 2.01 with 2.4 to say that the ball will reach because the height of the ball also impacts. So you need to finally you need to justify your answer and you need to write your conclusion also. By means of a calculation, determine whether or not the ball will pass into the goal. Finally, you need to write a statement also justifying your answer. It will reach the goal because the height of the top of the, or height to the center of gravity of the ball is this much after adding. Or else you can add the total height, total diameter of the ball as well for safer side. Because the ball has to be totally within the goal. So if it is, it's not only the center of gravity which should be inside the goal. Right? If the whole ball is inside, within, it will read. So you can do that also. So both are fine. We can consider 0.11 or 0.22. Right? Both are considered correct. You add the diameter to 2.11, 2.01. So 2.01 plus diameter, which is 0.22, is 2.23. 2.23 is less than 2.4. So the ball is within the ball is at a height of less than the height of the goal. So it will reach or it will pass into the goal. Right. Calculation wise, guys, there's nothing in this case. Right? S equals ut horizontally, find the time and use the time to find the height using S equals ut plus. These two are very famous two equations in projectiles. And we need to think a little with regards to the application. But the calculation wise, it's very easy. But then I looked at your answers and what I saw was some of us have still mixed up with the calculations. Right, more practice is required for you all. Air resistance would cause an additional force on the ball. Explain the effect this would have on the ball's motion. Right, if it is air resistance, it is opposite to the motion of the ball. So in the horizontal direction, the ball would not be able to maintain its constant velocity. So it will decelerate. If it decelerates horizontally, the ball will travel less amount of horizontal distance. So the ball will travel slowly. So it will take longer time to reach the goal. You need to write that air resistance acts in the opposite direction. So the ball will decelerate in the horizontal direction. In the horizontal direction. Ball will take longer time to reach the ball. Okay. Any questions, guys? Okay, so if you are silent, should I assume that you don't have any questions?
Think so, sir.
Okay, right. Thank you. Right. I'm going to show you a little video on an experiment that you're supposed to know with regards to the horizontal and vertical displacement of projectile motion. We did a related question during the last class. Let's watch the video and try to understand this experiment, right? After the experiment, I'm going to ask you all 5 questions. Should be ready to answer. Okay. Let's watch the video.
I'm going to show you a classic physics demonstration that's been around for over 100 years. It's called The Monkey and the Hunter because it features a monkey sitting in a tree and across the way from him in another tree, a hunter. Now, according to the story, and remember it was written by physicists, the hunter is in a tree at exactly the same height as the monkey and pointing his gun directly at the monkey. But the monkey's not entirely foolish and has figured out what's going on. So he's come up with a plan. He's going to watch the hunter very closely, and when he sees him pull the trigger, the monkey's going to let go of its branch and fall to the ground because he figures the bullet would just fly over his head. Now the question is the monkey right? And if not, why not? Let's see what actually happens. I think I actually got it.
Okay, you guys can see that the ball hits the monkey. The bullet is hitting the monkey. Can you try to think as to why that takes place? Why, the question is, why bullet hits the monkey? Write down this question. Why bullet hits the monkey? Right. I hope that you guys followed it from the beginning. If you have not followed it from the beginning, you won't be able to answer this question. If someone wants to watch that part of the video again, please let me know. Okay, so you guys are clear. I'm going to put you all into 2 breakout rooms. So you guys can discuss that as a group. And come up with your common answers and write your answer. 1 second. Now everyone here. I'm going to put you all into breakout rooms. Discuss your answer. And come up with your answer as a group. Right? There'll be 4 participants in one room. I'll give you 5 minutes maximum. Right? Okay, now everyone are back in the meeting. Guys, who are in the room 1? Can you all explain your idea?
So because we thought that the bullet and the monkey both they are subjected to
Yeah.
and so since they like let go, like since the bullet is fired and the monkey lets go at the same time,
Mhm.
the monkey gets shot. They meet
And
as one.
yeah. And so because the time where they meet is equal, so
Mhm. Right. Okay. Right. So the time is equal. Good. And monkey let go once the bullet is fired. Yeah. Right. Those are very good points. Very good. Anything else you guys need to share? Group 1.
no,
No?
no, sir.
No, so I think that's about it.
Right. Group 2. Okay. Very good. Group 1. Group 2. Can you guys share your ideas, whatever you discussed?
Yes, sir. So we discussed that the main principle that acted in this instant is that the vertical component of the motion of object is independent from that of the horizontal motion,
Mhm.
horizontal component of the motion.
Mhm.
So if you consider the vertical motions of both the monkey and the bullet,
Mhm.
we can find it as the equivalent to both the objects being dropped from the same height,
Mhm.
and the same gravitational acceleration acted on both the objects, so their vertical motions you can say is equivalent to each other.
Mhm.
And since the bullet also has a horizontal component of motion as well as the vertical motion,
Mhm.
the bullet meets the monkey at some point due to its horizontal motion, and thus the monkey gets hit by the bullet and dies.
Monkey dies also.
Maybe, probably, or gets wounded. I have no idea.
Right. Okay. Good. Very good explanation, Nidula. Did you discuss this with everybody? You guys discussed and came up with this explanation as a group, is it?
Yes, Siluni, me, Mitnis, and Sahanvi and Naditya.
Super. Very good. Right. I don't think I have to explain you all anything, right? I think the other group also heard it, and other group came up with the idea that both have zero velocity at the beginning and both meet because the time taken by both must be same. And second group explained it in very detail. And also, Nidula and your group is bringing up a very good point, which is the horizontal motion is independent from the vertical motion. That is one of the main key points that we need to know when it comes to projectile motion, which we discussed at the beginning, very beginning, before we start applying equations. Now, this experiment proves that horizontal motion is independent from vertical motion. That's why monkey who's moving vertically hits the bullet, which is moving horizontally as well as vertically. All right, so let's continue watching this, and the rest will be explained in the video.
Now, I wasn't really expecting to hit the monkey because this is quite a fiddly experiment to do, but let me quickly explain the setup. The monkey, as you've guessed, is just a tin can, and it's held in place by an electromagnet which is connected via this circuit. When I fire the bullet, it breaks a piece of foil here, disconnecting the magnet, so the monkey falls, and it starts to fall the instant the bullet leaves the gun. So that explains the experiment. But can you explain the physics of why the bullet hits the monkey? The key to understanding this demonstration is the fact that the bullet and the monkey fall towards the ground at the same rate, the same acceleration, due to gravity. So the bullet is at the same height as the monkey all the way across the lab. The fact that the bullet is also travelling horizontally makes no difference to how fast it falls. The horizontal and vertical components of its velocity are independent. Put it this way, if you just drop the bullet alongside the monkey, you'd expect them both to hit the ground at the same time. So why should the fact that the bullet's also moving horizontally make any difference? As you've seen, it doesn't. I'm going to show
Right. The both pink and yellow balls are falling at the same rate downwards. Yellow ball is moving horizontally while it's falling, have no effect on the vertical motion. Horizontal and vertical motions are independent from each other, right? You guys can draw this diagram. Sometimes they give you these diagrams in your exam, sometimes in MCQs, and sometimes they ask you to draw these diagrams. You should know that the vertical height of both must be same because they are falling at the same rate vertically downwards. And the horizontal distance must be always same for the yellow ball. I mean, it looks like it's getting bigger because we don't just measure, we're just looking at it. When you look at it, you feel that the horizontal distances are different. No, they're not. If you just draw vertical lines through the center of each of the ball, you will see that the horizontal distances of each consecutive two balls would be same. They're not different. But the vertical height, vertical displacement between two consecutive balls is getting increased. That is because the balls are accelerating. Right? Initially, you can see the balls are kind of overlapping. They are very close. But then gradually, the distances are increasing vertically. Right? But each of the frame of yellow and pink balls would be at the same level. Because the motion is only affected by gravity. If you ignore the R resistance, or if you think that the R resistance is negligible, this is a very important diagram. Okay. Guys, take down this. You better draw this because you have this too, but you better draw this. because you need to, and also write down these 3 points because you need to know how to draw it. The only way to practice is by drawing it. So quickly draw it and raise your hand once you are done with that. Let's do the exam question number 24. Okay, I'll do the same activity. I'll put you all into your I'll put you all into your breakout rooms again, right? You can work alone if you feel it's disturbance, but I prefer if you guys discuss with your friends, whoever is in the room. Yeah, you can check your answers. You can ask questions from them. And also you can shoot questions to me as well. Yeah, you can send a message. You can send a WhatsApp message, or you can send a message in the meeting chat. Once done, please share your answers. Hope this will help you guys to do it more effectively and also fast. Okay. I'm putting you all into groups. Okay, guys. Let's discuss the question. Please check your answers. I only got answers from some of you all only, but maybe the others are still doing the question. But anyway, please check your answers. The photograph shows a sequence of images of a bouncing ball. 20 images were taken per second. This is very important. 20 images were taken per second. Show that the distance ball fell between X and Y is about 0.4 meters. Right. How can we do that? The only information that we have is there are 20 images were taken per 1 second. Right. So you can use this to find the time. And also we have the images. Right. So the time between two images can be found because there are two images, 20 images captured in 1 second. So what will be the time gap between two images, or the time for one image? That would be 1 second divided by 20. Right? So between each two balls, two images, the time would be 1/20 seconds. Right? Something you need to figure out first of all. Right. How do we find the maximum height? To find the maximum height, we can find the time taken to reach the ground from the maximum height. We know that at the maximum height, velocity is 0. Like if you take motion from X to Y at t equals 0, initial velocity can be taken as 0, vertical velocity, because vertical velocity is 0 at the maximum height. And the time taken to reach the ground from the maximum height can be found using the number of images. There are 1, 2, 3, 4, 5, 6 images starting from the maximum height. So there are 6 gaps. So the time taken, there are actually 7 images starting from the beginning, and there are 6 gaps. So the total time would be time taken to reach, once again, time taken to reach ground from maximum height. That will be 1/20 seconds times 6, which is 6/20 seconds. Right. Initial velocity is 0. So to find the height, you can use S equals ut plus half at squared in the downward direction, because we consider motion from X to Y. Initial velocity is 0, so ut is 0 plus half. Since we are applying the equation vertically downwards, acceleration must be 9.81, that's positive, times 6/20 squared. It gives you 0.44 meters. Okay, shall we move to the next part 2? Okay. Part to use measurements from the photograph to calculate the horizontal velocity of the ball. How do you think we're supposed to use the measurements? How do you find the horizontal distance? To find the horizontal distance, you got to use S equals UT. If you're using equations, but then you don't have anything related to velocity. Yeah, then you can't use this. How are you going to use the measurements then?
So can you like physically measure?
Yes, you measure. What are you going to measure? Measure? What
Or the
should-
horizontal distance from X to Y.
Yes, you can measure horizontal distance from X to Y. That's right. So is it the horizontal distance? Should we take it as horizontal distance? Actual horizontal distance? Right. Now it comes to this photograph, the ratio of the vertical height and the horizontal distance must be same in terms of the like compared to the actual lengths, right? In both ways, the ratios must be same between the actual length and the length in the photograph. So you must use that. We found the actual height, which is 0.44. You can measure the height according to the photograph. We don't have, I don't know whether if you have a printed one, you could have measured it. Otherwise, you can just use the image also to measure. So when you measure it, it should come to about 5.7 centimeters. So 5.7 centimeters should be equivalent to 0.44 meters. So the 0.44 meters actual height is shown by 5.7 centimeters. So we can make a ratio. And then you measure the horizontal length between X and Y. When you measure that distance, it comes to about 3.8. Horizontal length. It's 3.8 centimeters. Yeah. Then the actual horizontal distance, we'll take it as X. So let's take the ratio. 5.7 centimeters. Check it the other way around. 0.44 meters is shown by 5.7 centimeters. Then X is shown by 3.8 centimeters. Right. You cross multiply, X is equal to 0.44 meters over 5.7 divided by 5.7 into 3.8 centimeters. So the X is about 0.293. Right. So you might have got different real values because of your size of your image. It doesn't matter, right? what I want is that you guys need to use the correct method, right? Otherwise, you should use the actual paper, right? This is not an actual paper. I have taken this image from a paper, and then when you guys open it or rather print it, you will get a different size. But what you need to understand is that you need to use the ratio in order to find the horizontal length. It's 293. You might get a different value. It doesn't matter. Right. So to find the horizontal velocity, you have only equation that we have is S equals UT. SC is 0.293. Horizontal velocity is unknown. We need to find that. The time taken should be the same time that we have recognized initially. So your answer can be between you can be between 0.49 meters per second to 0.61 meters per second. Right. Part B. The vertical position of the ball short time before bounce was always higher than the vertical position the same time after bounce. Explain the difference in height of the ball before and after each bounce. Why do we see a height difference before bounce and after bounce? Because at the bounce, the energy is kinetic energy. It's converted to heat energy so that the kinetic energy is lost. After bounce, the kinetic energy would be less than the initial kinetic energy before it hits the ground. So it won't reach the same height after bounce, right? So the kinetic energy is lost at the bounce. The kinetic energy is converted to potential energy when it goes up. So the height would be less than the previous height before bounce. The ball released with small horizontal velocity. The position of the ball in the first 4 images shown below. Drawing the first 4 positions of the ball had been released with the horizontal velocity. With no horizontal velocity. If it has been released with no horizontal velocity, it should fall directly vertically downwards, and it should be at the same height as the ball which was projected with a small horizontal velocity. Right, so the previous answer, I've been asked to repeat the previous answer. Okay. Write down at the bounds, kinetic energy of the ball is converted to heat energy. So kinetic energy after collision is less than before collision or bounce. Right? Okay, now. Right. Right. In this diagram, so this is same as that monkey hunter experiment. Explain why you have drawn the ball in these positions. There you go. Right. So why we have drawn ball in this position, right? When we were drawing this ball, we maintain the same position. I mean, it's falling along the same vertical line. And because there is no horizontal velocity, so it's fall vertically. Ball falls vertically since there is no horizontal velocity. That is because, right. So then the other thing is why they are at the same height. Because the vertical acceleration of both balls are same. They always have the same vertical height because the vertical acceleration is same for both balls. Right, guys, I'm going to conclude the class right now with this. You guys may do rest of the questions yourself. I'll be doing some selected questions based on the difficulty of the questions, and based on your queries, I'll decide the questions that I'm going to discuss in the class. And I actually want to start a new topic in the next class. as well, right? We'll see how it goes. But if you guys feel difficulty in this area, probably we'll have to discuss those questions. Sure. All right, we'll do that. So you can come up with all your doubts section, right? So I'll explain. If you have it, I mean, if you guys want me to explain like most of these questions, even I can do that, right? Doesn't matter. But I want you to try yourself. That's very important. All right, guys, then we'll wind up the class. Have a good day. Take care. Good night.
Thank you, sir.
Thank you. Bye.
Good night.
You're welcome, guys. Bye-bye.